Hello, good afternoon, everybody. This is the Alliance of Nurses for a Healthy Environment Research Working Group. And today we have Dr. Irene Yang, assistant professor from Emory University, who will talk with us today about her research on vaping. And I am going to share the screen and we will get started if I can do that.
Great. Can I go ahead and start?
Yes.
Great. Thank you so much. It's great to be here with you all. It's a nice, cozy little group, which I like. And thanks for the opportunity to share my work. For me anyway, it went back to the slide view instead of the presentation view. Yeah, that's great. Thanks. Next slide, please. So just a little about what I want to do with you today in our time together. Just talk about some background, describing what an e-cigarette is, what's the prevalence of vaping like in our country, and then discuss why I focus on vaping and oral health, and tell you a little bit about some preliminary work I did looking at the impact of vaping on the oral microbiome. And then we'll wrap it up with some preliminary takeaways and next steps. Next slide, please. So, what is an e-cigarette? There are lots of different kinds of e-cigarettes on the market, and they look different, they're called different things, but the basic kind of design of what an e-cigarette is similar across products. And these are the main components of the device. It's essentially a nicotine delivery device, and in the research world is known as ENS, so an electronic nicotine delivery system, ENS. But it is kind of powered by this battery here, which is that green square. And the battery powers up the atomizer, which is right next to it. And the atomizer is what heats up the liquid that is contained usually in a cartridge inside the device. And it heats it up to the point, well above 100 degrees Celsius so that the liquid can aerosolize. And then the vapor who puts their mouth around the mouthpiece, which is on the right end there, can suck in that aerosolized liquid and inhale it. Some of the earlier devices have an LED indicator, which is that pink bar over on the left. And especially if the e-cigarette looks like a conventional cigarette, like you kind of can't tell it apart, that LED indicator will burn red. It'll light up when the vapor inhales, just like a cigarette would. The little tip will burn red when a cigarette smoker inhales. So it looks kind of similar. Next slide, please. So the landscape of e-cigarettes is quite broad, and it ranges anywhere from an e-pipe, which you can see there. There are e-cigars even, and a whole host of different kinds of e-cigarettes. And you'll hear them called different things. Some people call them vapes or e-cigs or pens, vape pens, mods, or tanks. And they've been around now at least 20 years, depending on what you think of as the initial product, but kind of the evolution of this, what we now consider e-cigarettes, really started in the early 2000s. So in the last not even 20 years, it's gone through several evolutions of different kinds of categories of e-cigarettes. And Lisa, just to let you know, I have some animations. I should have thought of this before giving you the PowerPoint, but if you just hit the next, it should go to the first. Yeah. So the first generation is considered a closed system, not very modifiable. Basically, you could you use this particular e-cigarette, which looks like a cigarette and um, can be called a cigalike, and then you can't really change anything about it. You might be able to replace a cartridge on some of these initial first generation products to change out your liquid, but the device will stay the same. And for the most part, these closed systems, if you buy a particular brand of Cigalike, then you have to use that brand's e-liquid and cartridges. Next animation. The second generation is a little bulkier, a little bigger, um, largely due to the battery size. So it has more power and it is a little bit more customizable. So the vapor is able to um, inject their own liquid, whatever they purchase or order, and put it into the cartridge. And they can play around with what they're vaping. That way, it doesn't have to be restricted to that particular brand. The next animation. Now you can see we're kind of getting into bulkier box type devices. Sometimes they're called box mods. And these are called mods because they are highly customizable. So you can change out the mouthpiece. You can certainly change what kind of liquid you put into the device. You could even play around with the batteries on some um, devices to increase or decrease the voltage. It's really modifiable to the vapor's preference. And then we come to this kind of more recent e-cigarette history and the up until the last year or so, super highly popular Juul, which is known as a pod mod because Juul sold these little pods, which are the little cartridges you see there. That's what contains the e liquid. And then the device is the longer kind of stick, looks like a memory stick, which has all of the battery and the atomizer in it. And you just basically plug in the pods and vape that particular liquid. Um, it was especially popular among young people because, well, look at it. It's very attractive to look at. It's sleek. Um, it's colorful. Kind of looks like a thumb drive. So it was very popular among young people. There were even little skins that you could, like a little pocket you could put it in that came in different colors and patterns. And I guess it could be a fashion statement of sorts. Um, so that was very popular and largely contributed to, next slide, please, the surge in e-cigarette use among particularly among teenagers. So you see here there's kind of a steady increase and then between 2018 and 2019 there's like a huge spike, upward spike among teenagers. And it's really quite significant. So at the peak, it's like, almost 30% of high school students are vaping, and I'd say that looks like 10% of middle schoolers were vaping. Now, it has dropped since then, and it's not an insignificant drop, but it still leaves quite a few teenagers who are vaping. The drop's probably associated with that EVALI outbreak, the e-cigarette vaping associated lung injury, where there were a lot of people who got sick and some who even died related to their vaping. So it might be associated with that or the kind of legislative activity that was triggered by the EVALI outbreak. But you can still see there's up to 20% of high schoolers who are vaping, 5% of middle schoolers who are vaping. And the interesting thing is that of those vapors, the product that has really surged are disposable e-cigarettes. Next slide, please. And Puff Bar was one of the most popular disposables that are around. Puff Bar and Other products like Puff Bar are completely disposable. So you use this particular stick, it contains the device and the e-liquid that you'll vape. And then when you're done, when the e-liquid's used up, you throw it out and you get another one. Um, and these products and manufacturers who are making these basically flooded the market, the void that was created when Juul pulled out. So I don't know if you'll recall, but I think it was like 2019 or so, Juul decided to stop marketing its flavored products, responding to FDA legislation. These manufacturers were able to get around that legislation because it didn't apply to disposable products like this. So there are a slew of these disposable products. They come in the most enticing of flavors. This was the only Creative Commons product I could find, banana ice, but basically every fruit under the sun, Puff Bar offers guava and lime and watermelon, um, really marketed towards the young adults and the teen population. FDA has caught up and ordered them to take these kind of flavored products off the market. And if you go to their website, they say they've taken it off. But you do a quick Google search, it's easy to purchase these products online. Um, yeah, great. Next slide. Yes. So, what about beyond the teenage population? Um, it is kind of the young adult population that also has seemed to really taken up this particular product, the e-cigarette product. So you can see here the 18 to 24-year-old group um, are is the group that saw the kind of steepest rise in e-cigarette use. Next slide. And if we look at who are the vapors, so they are they tend to be men, young adult men again in the 18 to 24 age group, white and lower socioeconomic status. We also see that a bulk of the vapors are either current smokers or former smokers, either recent or um, in the past 1 to 4 or over 5 years. So people who've, switched over to vaping to quit cigarettes because the the idea behind it, of course, is that vaping is healthier than e-cigarettes. And the question is it really? Next slide, please. Um, so that is the question. Is it safer or better for people to vape rather than smoke? Is it safer for people who are former smokers to switch to vaping, or is it okay for naive people who've never smoked to begin vaping? So that's the big hot research question. What we do know, next slide, please, is that vaping is not just harmless water vapor. It's not water vapor that we're inhaling. And we're learning as more and more research comes out that there are a lot of constituents of e cigarette aerosol that are known toxins, known to be toxic to human health. And there are other products like flavors or flavoring agents like diacetyl, which are FDA approved to be in a lot of our foods that we ingest, but may be dangerous for us to inhale, especially when they're heated. So, next slide, please. There are still a lot of questions about vaping, what it does to human health. Does it affect behavior? Does it affect growth and development? What about secondhand smoke exposure? Not smoke exposure, vape exposure. We know that secondhand smoke exposure is bad. We don't know if passive vaping exposure is bad. Does it do anything to reproductive outcomes? Can it help people quit smoking? Is it a gateway behavior? Lots of questions, and for the most part, although there is more and more research coming out about vaping, the jury is still out on most of this. So, what I tackle is a tiny little piece of that iceberg. Next slide. And that is, what does vaping do to the oral cavity? And the reason I focus on that, there's a few reasons. One is that it, the oral cavity is the primary site of exposure. So when a vapor inhales the aerosolized e liquid, um, that liquid is first hitting that person's mouth, hitting their tongue, their teeth, their gums, their oral mucosa, their throat. And we also know that a lot of exposures where the mouth is the first site of exposure, we know that there is an association with a lot of those exposures and oral health. So, for example, smoking is a pretty direct comparison. Smoking is terrible for a person's oral health and other health measures. So, um, that makes oral health and the oral cavity an interesting place to look at to see what does vaping do to oral health. Beyond that, next slide, please. We know that um, there is an oral systemic connection. So we've known for a long time, since the late 19th century, that there's lots of kind of epidemiologic evidence that suggests a very strong association between the state of one's oral cavity and extraoral conditions. So, anywhere from brain health, cognition, to certainly there's a relationship we know between oral health and respiratory disease, um, colon cancer, pregnancy outcomes, heart disease, even rheumatoid arthritis. Um, so that's another reason that it's really interesting to look at vaping's impact on oral health, because there can be an association with other disease conditions. Next slide, please. So that's really what this vein of my research looks at: is what does vaping do, or does it do anything to the oral cavity? And then how is that the state of a vapor's oral health associated with a given extraoral condition? And to tackle that, animation, if you hit the next slide, I really wanted to just focus on this part of the equation. What does vaping do to the oral cavity? Next slide. So I undertook a systematic review just to look at what the literature says about this particular topic, and looked at 99 articles. Next slide. To look at what's out there, and was able to categorize it into 7 different effects. And the majority of, I have to say that the majority of the literature out there is not very rigorous yet. For example, the mouth and throat effects, most of those studies that I looked at reported these effects as very descriptive, adverse effects that participants were experiencing. It was cross sectional, so not very rigorous. But it did seem to suggest that some of the symptoms experienced by vapors, mouth and throat symptoms, were mild, temporary, things like dry mouth, dry throat, burning, irritation, maybe needing to clear the throat frequently, bad taste, bad breath. Researchers who compared groups like vapors with smokers, conventional smokers, or non-vapors, non-smokers, um, found that for the most part, these symptoms, they existed for vapors, but they were more severe in smokers than they were for vapors. There were not very many studies on dental effects, but there were reports, kind of adverse effects of toothaches, changes in tooth colors. Cavities were found to be associated with vaping, abscesses, and tooth sensitivity. Research at the molecular level is still inconclusive with the research that's out there, though. It does seem to suggest cytotoxic, genotoxic, or oncogenic effects, with reports of reduced cell proliferation and viability, altered cell morphology, promotion of apoptosis and necrosis, DNA damage, and increased transcription of pro-inflammatory cytokines. We did find several case reports of trauma or accidental injury, and while it's not common, the effects are quite devastating and usually attributed to the explosion of the battery. Batteries, by the way, are not FDA regulated. And the injury ranges from, completely doing major dental damage to burns were frequently reported to even spinal cord injury. There was one case where the mouthpiece was propelled through the person's throat and into the spine, and the person had a spinal fracture. So it's not an insignificant effect. Most of the trauma that's incurred happens around the oral cavity. I was particularly interested in periodontal effects and oral microbiome effects, which really speak to that oral systemic connection, and I'll talk about that a little bit later. Periodontal studies found an association between vaping and periodontal damage. So vapors had higher levels of plaque, they had deeper subgingival pockets, they were more likely to have inflammation and higher levels of inflammatory markers in their local gingival crevicular fluid or saliva. But similar to the oral mouth and throat effects, these periodontal effects were less severe than what would be found in conventional smokers, although they were more significant than what was found in non-vapors. In terms of oral microbiome studies, there were only a few, and there have been a few more since this review has come out. But it was really kind of equivocal, with some studies finding that vaping did change the oral microbiome and others finding no effect at all. Next slide, please. So the oral microbiome is really kind of what I focus on. And the reason is that the oral microbiome is closely associated with oral disease. So if you think about the two most common oral conditions, which are cavities and gum disease, they both have a bacterial etiology. So if we want to understand the impact of vaping on oral health, it's really critical to know what happens to the oral microbiome. Next slide, please. And there's, I think, maybe two animations here, and you can go ahead and set them off. So the oral systemic connection, so certainly it's important to understand if you want to know a behavior's impact on oral health, it's important to understand the oral microbiome. But if you also want to know what's the impact of oral health to systemic health, it's important to understand the oral microbiome. And the reason is that we don't know for sure, but we think that the mechanism that might explain why oral health is related to systemic health has to do with the bacteria that live in our mouth, the bacteria and other organisms. The one theory on the left here suggests that actual bacteria in our mouth somehow leaks into our circulatory system, travels through our circulatory system to some other part of our body and triggers a disease process. And there's evidence to support this particular theory because people have found oral pathogens on non-oral parts of the body, like placenta or brain. The other theory, which is on the right, suggests that maybe it's not necessarily those organisms. Maybe it's something that's triggered by the presence of those organisms. Maybe it's lipopolysaccharide, or maybe it's the inflammatory products that are triggered when someone has periodontal disease. We know that they get puffy gums and bleeding gums, and there's a lot of inflammation going on there. Maybe some of those products leak into those blood vessels and get into the systemic system, causing disease. Next slide, please. So I really wanted to get at the oral microbiome, and a colleague of mine, Dr. Jeannie Rodriguez, and I, we got a little bit of funding from the Hercules Exposome Research Center at Emory, not to look at the oral microbiome at all. Our intention for this study was really to look at passive e-cigarette exposure in children. And that happens to be an area of particular interest for my colleague, Dr. Rodriguez. So the objective of this study was just to see if we could detect exposure in children using saliva and exhaled breath. So we were recruiting parent vapers and their children. But it was a great opportunity for me to collect some oral specimens from the parents, which is what I did, and you can go to the next slide, Lisa, which is what I did to look at the oral microbiome. So for this part of the study, we enrolled 18 daily vapers and 18 non-vapers, non-smokers, and collected oral swabs from them. They swabbed their buccal mucosa, tongue, and hard palate. We sequenced the V4 region of the 16S marker gene and used the human oral microbiome database to reference the sequences. Next slide, please. Our sample of 36, or our sample of 18 vapors, they didn't quite look like the distribution across the country. So they were quite different, probably because of we used convenient sampling and we were recruiting parents. So they were older, in their mid-30s. Our sample was mostly women, non-white. They were non-partnered, over high school education, tended to be on the lower socioeconomic the lower end of the socioeconomic range, and were not employed full or part-time. Next slide. When we looked at the microbiome, controlling for those factors that were significantly different between the group, we were pretty excited to find that the two groups had different bacterial ecosystems. So this is a PCOA plot that describes the beta diversity, which is just a global measure of how different are these bacterial ecosystems between the two groups. And you can see that both of these ways of looking at it, Bray-Curtis measures difference in relative abundance of species, taxa, and Jacquard measures presence or absence of taxa. So for both of these measures, our two groups, vapors and non-vapors, had significantly different microbiomes, controlling for race, sex, because we had predominantly women, partner status, and conventional smoking, because we had several of our vapors who also smoked at the same time. So controlling for all that, significantly different. So that was pretty exciting. Next slide. We wanted to then drill down to see, well, what was different about these two ecosystems? And I really think we were limited in terms of our power to detect taxa differences at the taxonomic level. The only taxa we found that was different was Vianella. And unfortunately, it was not a species identified Vianella. Our sequence didn't match up with any sequences in the Human Oral Microbiome Database. So this is an unclassified Vionella, but you can see that the vapors had a significantly higher relative abundance of this particular Vionella species than the non-vapors. What do we know about Vionella? It is very common in the oral cavity, actually throughout our alimentary tract. It's found, we know, within the oral cavity on mucosa, but also on plaque, both above the gum surface and below the gum surface. And Vionella species, while not known to be pathogenic, have been associated with periodontal infections and other oral infections like endodontic infections. And this particular species, Vionella parvula, although we don't know if this is Vionella parvula, but Vionella parvula is particularly suspect. And even though, again, it is not pathogenic, they think that it's a bridging species where something about V. parvula's metabolism attracts other pathogens like Porphyromonas gingivalis, which is a known periodontal pathogen. And Vionella species have also been linked with systemic infections like endocarditis and sepsis. Next slide, please. So I mentioned that in our vaping group, they were not exclusive vapors. So 10 of them were dual users, meaning that, yes, they vaped, but they also smoked. And we decided, it'd be interesting to look within the vaping group and then compare the dual users with the people, the 8 people who only vaped. And for this comparison, we actually detected a difference in alpha diversity. So we did not find this when we looked at the two groups, vapors and non-vapors overall, but between dual users and exclusive vapors, there was a significantly higher alpha diversity among dual users. So that only manifested in that Chow index, and Chow measures kind of the richness of the microbiome that you're measuring. And basically, what this is saying is that dual users have way more bacteria in their mouths than exclusive vapors. And why does that matter? It matters because higher richness or alpha diversity is associated with oral disease, both dental caries and periodontal disease. Next slide. We also saw a difference in beta diversity, also, although not in the Bray-Curtis measure, that was not significantly different, but we did find a very significant difference in terms of Jacquard. And the Jacquard index, again, it looks at presence absence. So this particular plot is telling us that the dual users and the exclusive vapors are really different in terms of what kinds of bacteria are present in their mouths. Next slide, please. And these are the 10 bacteria that were significantly different. So basically, these 10 bacteria are much more likely to be present among the dual users than they are in the exclusive vapors. And when I looked at these taxa, many of them are associated with oral disease. So, for example, Tannerella forsythia is a known red complex organism. It is part of the most severe periodontal pathogens included with Porphyromonas gingivalis that is known to be pathogenic for periodontal disease. Porphyromonas endodontalis, also known to be associated with periodontal infections and endodontal infections. All the Prevotella species have been associated with oral disease. Streptococcus aeruginosus is associated with abscess formation, both in the mouth and in other places of the body. So, what does this all tell us? Next slide, please. Although it's preliminary, and there were definitely limitations in terms of our power and the way that we sampled our population and also our oral microbiome, our results do suggest that there is a definite change in the oral microbiome that's related to vaping, um, and that change, however, it doesn't seem to be as great as what is experienced by dual users, people who smoke and vape, and that the change is suggestive of oral disease. Of course, we didn't diagnose oral disease in our study, but those organisms that we identified that were either differentially abundant or more likely to be present are associated with oral disease. Next slide, please. Why is that important? It's important because hopefully, as I continue this vein of research, it will give us more solid data to support guidance that clinicians can offer to people who are vapers. Um, there's potential for the development or learning about exposure or risk markers, people who we might be able to detect people who are more likely to be in a preclinical state of oral health or oral disease, or possibly even a form of systemic disease if we find that there is this oral systemic connection. And all of that supports clinicians' ability to provide and monitor for precision medicine. Next slide. So I'm not sure how many people are on the call or, if there are questions, but I wanted to tell you my next step. So Dr. Rodriguez and I actually subsampled our vapors, and we did a qualitative study, ran some focus groups in the middle of analyzing the data to look at their perceptions about vaping on their health and on their children's health, and also some of their motivations around vaping. Really interesting. And then we are funded on an administrative supplement to look, again, not necessarily at the oral microbiome, but our administrative supplement is looking again at pediatric passive exposure, this time measuring the actual exposure um, using wristbands that children will be wearing in their home for a week, and then looking at the relationship between that exposure and respiratory measurements. But I will be tacking on oral specimens again for the parents, and I'll be collecting saliva this time to look at salivary microbiome. I think it'll really give me a good global picture of the oral microbiome. And I also propose to look at the lipidome, which will get at not only describing the microbiome, but help me understand what some of the functional mechanisms that are happening and that are associated with the microbiome are. So those are my next steps. And then now, questions. And also a little reminder to take care of your oral health.
What got you interested in this particular type of research with the saliva? What floated your boat on it?
Well, I started out, my area of research when I was a doctoral student was prenatal smoking. And so that was my area. But as I went on and went my research training as a postdoc and then junior faculty, my research area shifted to looking at the microbiome. And I didn't want to let go of that smoking piece and had always thought, I want to look at e-cigarette use among pregnant women because I'm a nurse. I was a bedside postpartum newborn nursery nurse, and this was years ago, but before vaping, I think was super popular. But I remember taking care of women who had e-cigarette products in their bags and not knowing what they were. Um, so I always was interested in vaping, and then kind of put that together with this new research trajectory that I took on, which was the microbiome. And that's kind of the, the synthesis of those two strands of research interest.
And Irene, there's a question from Jessica. I can read it to you. This is
Sure.
Jessica Kastner. Thank you for this interesting presentation. For researchers interested in lung health and measures of exhaled biomarkers and physiologic measures, can you comment about how the oral microbiome, oral health considerations as confounders or covariates in lung health measures? Interesting.
Yeah, that's a good question. I think I don't know how much of like say you were measuring the microbiome, like an uh, exhaled breath microbiome. I don't know how much of the oral microbiome would be contained in there because generally, for example, me, if I wanted to measure the oral microbiome, I would not collect exhaled breath.
I think she might mean like you can collect exhaled nitrous oxides or exhaled carbon monoxide, exhaled like other things that can measure lung exposures to things that can damage lungs. So I
Yeah,
guess I don't know, Jessica, you want to maybe you can't um, unmute,
unmute.
but I think
Well, what I
mhm.
was gonna say is that, to be really rigorous, because I think certainly even if it's nitrous oxide that you're measuring, um, there are certainly metabolic products that are put out from oral microorganisms. So to be rigorous, if you are measuring exhaled biomarkers, um, it would be beneficial in a from a research standpoint to understand what kind of organisms are in the mouth to be able to control for that. But also, the oral microbiome research is an emerging field. So especially when it comes to metabolic products of oral microbiome, we don't know a whole lot about what's going on there. So it would be great to measure, as and to be able to control for if there is something that you see. But um, yeah,
I
it's a
wanted to,
great question. And I
yeah,
saw you were typing. Mhm.
I also wanted to say, that I got one of these Hercules pilot grants through Emory, and we collected nasopharyngeal swabs on infants in Guatemala in the Happen trial. So we're actually,
Mhm.
your presentation was so clear, and I like collected data on the microbiome and don't even understand how to process or analyze or present. So I found it so helpful. But we would also be kind of looking at this group that's exposed to cooking fuel that's wood versus cooking fuel that's gas, and see if
Mhm.
there are differences in the mothers and the infants. It's kind of, we're looking at them at birth, mother infant, nasopharyngeal,
Mhm.
and again at 6 months, mother infant
Interesting.
nasopharyngeal, to see between difference and across time difference. And so we haven't even gotten to the microbiome analysis, but the data is,
Yeah, but that'll be really interesting because you're looking at between mom and baby, you're looking at different kinds of fuel, and then you're also looking across time. So,
ugh,
um,
you want to do the
yeah.
analysis for me?
Yeah. I'd love to. I can't wait to see it though.
Oh God, it's just one of those things that is like, your presentation was so interesting, and even with 36 people, you found statistically significant things that are in the right direction as well.
Yeah.
So good.
I mean, so important because I have a great biostatistician that I work with, and just to be able to, because I would have done a very gross comparison, vapors and non-vapors, and not really known how to control for those other. I mean, smoking and sex were two huge um, confounders there in that sample, and I wouldn't have known how to control for it. But yeah, the biostatistics part is so important.
Yeah, for sure. What
Mhm.
is lipidomics? I don't know what that is. Is that is that
Lipidomics is a subset of metabolomics. So
okay?
it's metabolomics, but only the lipid.
Okay, so that there you can see the functional, like the functional aspects of. Okay, 'cause we do
Yeah,
have alone too, but I that's yeah. I was just
yeah, and
looking.
especially if you're interested in inflammation, which I am, as kind of the mechanistic pathway, there a lot of the metabolites in the inflammatory pathway are lipids, lipid derived or lipid precursors.
I see. Any other questions from people? I know we don't have a whole lot of time, but 2 minutes. If anybody wants to ask any questions.
This is Luce. I have a quick question that's very basic in terms of your approach with the oral microbiome. In modern day, people are big coffee drinkers, big soda drinkers, and I can't help but think from generations past to now that that has really shaped the oral microbiome. Is your science and the science of the oral microbiome, have you looked at those sort of baseline changes, and is there some sort of general comment you can make on just oral health for contemporary Americans when they drink these products in such a daily way with so much caffeine and sugar and what have you?
Yeah. The caffeine part I'm not really sure about, Luz. I I've not read anything. That would be an interesting question because I happen to be a big caffeine consumer. But sugar most definitely affects the microbiome, and we just all know that in commonplace knowledge. And then it definitely shapes the oral microbiome in terms of research considerations. You'll notice I did not collect dietary data, so I wasn't able to kind of measure that or consider it. I have since then, but I'll be honest, it's really hard to know how to use that data in terms of analysis. So, if I collect a food frequency questionnaire, what am I going to do? Just I guess maybe look at macros and sugar, or look at processed sugar and then see if I can use that as a control variable. I think it's a really important consideration. I haven't figured out in my research how to integrate the dietary data, but it's definitely relevant for not only the oral microbiome, but other microbiomes as well.
I have a follow up to that. The reason I bring it up is because when I think about the oral microbiome and having it be healthy, it brings up the concept of food as medicine, right? So, if we wanted to improve our microbiome, just like we might want to improve our gut microbiome, it
Mhm.
seems a simplistic approach, but can we change or tweak our diets a little bit to get that more quote unquote positive microorganisms? I'm thinking of the intervention piece is what my brain is kind of moving towards.
Yeah, I love that question, Liz, because I haven't really thought about it. And we don't traditionally in the oral health world, beyond like don't drink sugary sodas or, candy. Beyond that, you don't really think, at least my mind hasn't gone to diet as intervention. It's usually hygiene or behave like other behaviors like smoking or vaping or alcohol consumption. So that's a really interesting thought. Maybe we can collaborate on an idea, Liz.
I'm always up for collaborations. It makes the job much more fun.
For sure.
Well, thank you so much, Irene, for
Mm.
your presentation. The pictures were amazing. I love the tongue with all the shiny microbes all over it. I was
Oh,
so,
thanks. Shutterstock.
oh my gosh, so good. And we will be posting this on our YouTube channel, and we'll send you out the link as well. And really appreciate you coming in and
Thank
talking
you
about
for
that.
inviting me. Thanks, everybody.
Okay, bye bye.